Now in question number 3, a little bit of a different idea here. They're going to tell you now here that these shapes are exactly the same, and what you're supposed to do is find the unknown measure. So they're going to give you some different things in terms of the angles and the sides to find, and what you're supposed to assume here based on what they've said is that these two shapes are exactly the same. So we know there has to be some type of correspondence here because things have to match up if the shapes are congruent. That's the only way the shapes are congruent. Usually what I would tell you to do here is take and rotate that shape in your head so it has the same orientation as the shape you have. Now obviously I can't cut that shape out and rotate it as is on the notes, so what we're going to have to do is match things up. So let's start actually with finding the B part here, the sides. So what we want to do is go ahead and match this up as we go around the shape. So let's start with the top here. All right, I got a 30. It's got to match up with a 30. So come down here and match up with that 30. Now, you're going to say, how did I know not to match it up with that 30? Well, I'm going to show you. Quite simply, I'm going to go around the shape in order. So I'm going to go this way clockwise. So my order here is going to go 30, 20, 17. So I want to go the exact same way around the other shape because they can't mix and match the sides like that. They just can't say, oh, I'm going to put the 20 over here and then the 17 down here. If it's in this order in this one, it's somehow got to be in the same order in this one. So that being said, 20 would be next, 20 and 20 next in order. Then 17, 17, 17 in order. Then my other 30s, 30 and 30 in order. Then 23, 23 and 23 in order. And then the last one is 28 here. So I'm going to take that 28 and go around. Well, that's the one we didn't know because that's the last one remaining in the order here. So that has to be 28 as well. And so we found the missing side being 28. Easy. You're not doing any mathematical calculation to find it here. All you're doing is you're going around the shape and finding what side is missing. Easy. Now, as far as the angles, you actually have a couple different techniques you can use here to find the missing angle back in part A. We have here a shape with 1, 2, 3, 4, 5, 6 sides. So you could use the sum of the interior angles formula you learned yesterday, n minus 2 times 180. Subtract off all the angles you have, and that would give you the remaining angle. The other thing you could do is simply go around the shape in the same way that we did with the sides and go ahead and match up the angles and figure out what's missing here. Lots of different options. Since we're supposed to be talking about congruent figures, let's go around the shape though and figure out what's missing here. So we're going to have the same type of order deal going on here. So let's start here at this 122. I see 122. I see 122. I'm going to go counterclockwise this time, so the next one I see is 114. Here's 114. I've got 123. I got 123. Notice they're going in order. All right, I'm not like here, then jumping over here, then up here, then down here. They're going around in an order as well. I'm going counterclockwise here. I just happen to be going clockwise this one. Not a big deal. I've got 130 and 130. I've got 121 and 121. And the missing angle here is 110. Well, that means this angle here has to be 110 because that's how we match them up. And indeed, as you can see from the answer that was already written, the missing angle measure also has to be 110 degrees. And that's all you got to do. Notice we never did any calculations there. We could have, but we didn't do any calculations to find that. It's just seeing how the shapes match up. Okay, let's go ahead and take a look at the check it out concluding examples here. Number 1, we're supposed to determine whether the triangles are congruent. So here we're supposed to use the side rule to figure out if the triangles are the same. So let's see if we can match up our sides here. Well, I got a 6 and a 6. That's good. And I've got an 8 and an 8. That's good. And then I've got a 10 and a 10. Well, since we've got 3 sets of matching sides here, this does qualify for the side rule, and so we're going to say that these triangles are congruent. Now, this is the first time we've had this really, so what we have to do here is write our congruence statement. Now, when we write the congruence statement, we just don't write this in any old way. The congruence statement is written in a way that the angles would also match up. So take a look here. First letter we wrote here was A. Well, notice what A is. A is where our right angle is. Well, over here, our right angle here is D. So it's no coincidence that D is the first letter over here on this one, because the first letter and the first letter here shows the matching up of the right angles. All right, we can go any way we want, but they went towards B next. So notice what they did is they went from the right angle and covered up the 6 side. Well, we're going to have to do the same thing over here, cover up the 6 side. So if we were at D, to get to the other part of the 6 side, we'd have to go to E. And that's why those are the second letters. That also means that angle B is the same as angle E. And then C, of course, the only remaining letter, with F, the only remaining letter. That also means that angle C is going to be the same as angle F, because those are both the third letters. And that's the way you write a congruence statement. You just don't say, well, I want to write ABC is the same as FED and be over with it. The congruence statement actually tells you how the angles match up and the sides match up. All right, in the concluding example here, we're asked to determine the unknown measures in the set of congruent polygons. Okay, so let's take a look. Going around the shape here, I've got this flat side here, which is 4. Well, if we take a look at the other trapezoid here, or the other quadrilateral rather, sorry, taking a look at this other quadrilateral, we have this other flat side down here, which is 4. Of course, they have to be congruent because they have the same characteristics. So this one is our other 4. We can go around and prove that if we want to. Look here, on the side that goes from 120 degrees to 60 degrees, that's our 6. Well, here's that set as well, 120 to 6, which is also how I give away that answer. On the bottom here, the side that goes from 60 to 45, it measures 8. On the side that goes from 60 to 45, it measures 8 as well. Not coincidental. On the side that goes from 45 to 135, it measures 5. On the side that goes from 45 to 135, it also measures 5. So actually, we found more than they wanted. Now, as far as the angles, again, it's just a matter of me going around here in order to find what I don't know. So I've got a 45 matches up with a 45. Then a 60 matches up with a 60. And then a 120 would be a 120. That's how we filled in that one. And the last one, 135, matches 135. And there you go. You found the missing angles simply by following the order around. No calculations required. Of course, again, we could have used that formula. We could have used that n minus 2 times 180 here formula. Of course, since these are quadrilaterals, all you really would have had to do was subtract from 360 what you got here. 360 minus 60 is 300. Minus 135 is going to give me 165 minus 45 is how I'm going to come all the way down here to 120. And of course, that way we've also proven that this is 120 degrees. Unknown angle is 120 degrees. The unknown side length measures 4